Okay, notes for section 14.2 talks about conditional probability. So what is conditional probability? Conditional probability is a measure of the probability of an event occurring given that another event has occurred. So go ahead and pause and write that definition down. This can be noted as P of event A given that event B has occurred. So this straight line is letting us know that it's given that the second event, B in this case, has occurred. A lot of times this can be noted with a Venn diagram. So we can draw two circles. And we can talk about this being event A, and over here will be event B. So we want to know the probability of event A occurring given that event B has occurred. Well, all of this would be event B. So the possibility that you're trying to find out A occurring given that B occurred would be this portion right here, because that's A given that B has happened. Example 1 shows you how this would work if you're going to use the Venn diagram. So we have 20 students are on the track team and do not get an A in social studies class. 16 students get an A in social studies class but are not on the track team. Then we have 8 students that are on the track team and they get an A in social studies class. So part A wants us to draw the Venn diagram and insert the numbers so that we can represent this situation. So let's label these circles. Let's label track team members on the left, and on the right we'll say A in social studies class. So when we fill this in with the numbers, we have 20 students that are on the track team that do not get an A. So they go into the left portion of this Venn diagram. On the right portion of the Venn diagram, we have 16 students that are getting A's, but they are not on the track team. And then those 8 students that are on the track team and get A's go in the middle because they're part of both of the circles. Okay, what is the possibility that a particular random student is pulled and will be on the track team? Okay, so how many students are on the track team? And when you look at this Venn diagram, the track team is represented in this circle. And we have a total of 28 members on the track team. Great. Now we have to put that out of the total number of students we're talking about. Well, now that is talking about all of the students everywhere. So we have 28 plus the 16, which ends up giving us 44 students for a total. Okay, both of these are divisible by 4, so you always simplify, and you end up getting 7/11. Let's erase our lines because we're going to think about it a little bit differently now. Example C goes into conditional probability. This part asks, what is the probability that a particular randomly chosen student received an A in social studies given that the student is on the track team? So we need to talk about just those that are on the track team. So those that are on the track team are in this circle. And I want to know, of those, how many get an A? And the answer is 8. So we would write this as 8 out of those that were, it's given that they were on the track team, 28. Both of these can be simplified by 4. So we get 2/7 for this answer. Okay. There is a formula for conditional probability. So if we have the probability of event A occurring given that B occurs, we can write this as a quotient. So this would be the probability of event A and event B occurring. So remember, this means the intersection, and that's when we have the and group. So in the Venn diagram, the and group is here because both of the situations are occurring over the probability of just B occurring. Okay, so let's, for example, 2 and 3, we're going to think about this using the quotient instead of the Venn diagrams for these particular examples. So it says, what is the probability of 2 children being girls if we are told at least one is a girl? And we have a little typo here. Okay, so let's write that. Probability of 2 girls given that we're told at least one is a girl. So in this particular situation, let's think of what our options are. We're talking about 2 children. So we have a possibility of both of them being girls. First one being a girl, second boy. First one being a boy, second one being a girl, or both being boys. So our quotient for this particular question would be the probability of 2 girls and at least 1 girl, which I get is a little bit of a goofy example because of the fact that if you have 2 girls, then yeah, at least one is a girl, over the probability of at least 1 girl. All right, so let's write this out. When we look at our 4 options, which of those have the possibility of 2 girls and at least 1 being a girl? And when you look at these, the only one that gives us 2 girls is the top one. So we have 1 out of 4. Now, for our denominator, we need the probability of at least 1 girl. Okay, well, there's more options here. This top one for sure. The second one is a girl, boy. Yeah, at least 1 girl. The third one is boy, girl. Yep, there's at least 1 girl. And then the bottom option, that's not a possibility because there are no girls there. So the denominator would be 3/4. Now to solve, we would multiply by the reciprocal of the denominator to get rid of that fraction down there. And then you end up with the 4's canceling on top, and we have 1/3 as the probability of having 2 girls, with given that at least one of them is a girl. All right, now example 3. Example 3 wants to know, what is the probability of 2 children being girls if we are told that the oldest has to be a girl? So when we write probability of 2 girls, given that the oldest is a girl. All right. Well, our quotient would be the probability of 2 girls and oldest being a girl over the probability of the oldest being a girl. All right, so let's write our options again to the side here. We have the 2 girls, girl then a boy, boy then a girl, boys for both options. Okay, so for our numerator, the probability of 2 girls and the oldest being a girl, well, this is the only one that has 2 girls. So once again, 1/4 for our numerator. The problem is very similar to example 2, but your denominator is not the same as in example 2, because when you look at your 4 options, when we ask which options have the oldest as a girl, the first option does, the second option does, and that's it. Because option 3 has a boy as the oldest, and option 4 has boy as the oldest. So here we have 2/4 for the denominator. So then when we go to solve, you multiply by the denominator's reciprocal, and you are left with 1/2. Okay, the last thing I want to mention about this section is a complement. And what is a complement? The definition is all other possible outcomes. So, for example, the complement of heads on a coin is tails. You can say for a coin toss. And then the complement of winning would be losing. All right. So you understand, you get the point. What you also need to understand is that the probability, if there are two events, if we have event A and event B, and they are complementary to each other, then one or the other is certain to occur. So the probability of A plus the probability of B occurring would equal 1. And 1, remember, equals 100%. So all of our numbers that we're going to get when we're talking probability are going to be between 0 and 1. You can only get up to 100%. So most of the time, you're going to end up having a decimal or a fraction. All right. This concludes your notes for section 14.2.